Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you all are watching my channel Chemistry Solutions. Chemistry Solutions. So today in this lesson we are going to do the Cambridge IGCSE paper 4 theory extended 062042 February March 2025. So first question is, using numbers only, state the percentage of oxygen in clean dry air. So in clean dry air we have that is 21% of oxygen. We have nitrogen, that is 78%. Argon is a noble gas, present as 0.93%, and carbon dioxide gas is present, that is 0.04%. B part, typical operating temperature in degrees centigrade used in Haber process. What basically Haber process is? Haber is a process in which ammonia is manufactured. So nitrogen plus hydrogen will give us ammonia in this process. All are in gaseous form. Iron is used as a catalyst, 200 atmospheric pressure, and whereas the temperature is 450 degrees centigrade is the temperature. Number of atoms in a diatomic molecules. Di means 2, so there are the number of atoms. 2 atoms are present in a diatomic molecule. Maximum number of electrons in the second electron shell of an atom. So it is 8. While we do the electronic configuration, we write 2, 8 and 8. 8 are the maximum electrons present in the second shell. Number of hydrogen atoms in an alkane with 7 carbon atoms. Alkane basically are having the general formula CnH2n plus 2. If we will put the value of C carbon 7 heptane, we will get the value 16. So 16 will be the hydrogen atoms present in a heptane molecule with carbon atoms with 7 carbon atoms. Number of particles in 1 mole in standard form. What are basically the number of particles are? Number of particles are basically our number of ions, molecules, and atom. To somehow number of electrons also come under these headings when you have to calculate the number of electrons as well in 1 mole. Then we will use this standard form, that is 6.02 into 10 raised to power 23. So this one is the Avogadro number. So next question is, in second question, A part, state what is meant by the term ionic bond. So in the syllabus, ionic bonds are formed by the transfer of electrons between metals and non-metals. But in your syllabus, the definition which is given to us is the electrostatic force of attraction. Electrostatic force of attraction between oppositely charged ions always remember that the metal forms positive charge by losing their electrons. So electrostatic force of attraction between oppositely charged ions in metals and non-metals. Metals contain positive charge and non-metals have the negative charge by gaining the electrons. So next question is, potassium sulfide is an ionic compound. Complete the dot and cross diagram of the ion potassium sulfide. So potassium has 19 electrons. Let me complete this. Potassium has 19 electrons, whereas sulfur has 16 electrons. Potassium again has 19 electrons, and it is present in the first group. It will lose its one electron. After losing one electron, it will gain 1 plus charge. Sulfur will gain 2 minus charge. Again, potassium will gain 1 plus charge. So here we have to draw the number of valence shell. It will lose its outermost lose its one valence electron. The rest of the electrons will be drawn like this. Electronic configuration for the ion after losing the electron will be 288, similar with this potassium atom. It will lose its one electron and will attain noble gas configuration. Okay, now come towards sulfur. Sulfur is a non-matter. If we will show it with cross. So do not forget to draw 2 electrons are taken up by the potassium atom. So the electronic configuration for sulfur will, by gaining the 2 electrons, 2, 8 and 8. The charge will be 2 minus because it has gained 2 electrons. So next question is, 1 chloride ion is going to surrounded by 6 sodium ions. So this is the ratio through which they will, this negative sign has given to us, we will add plus here, plus minus, plus this, there we are going to show the electrostatic force of attraction between oppositely charged ions. Okay, plus with minus and then plus, so we have to show this along it. So if we will move on towards next part, say the name given to any positive ion. So positive ions are called as cations. Ionic compounds can be decomposed by the passage of electric current using inert electrodes. So this is the process of electrolysis, where electrolytic cell is being used. Write the ionic half equation for the reaction which take place at the anode when molten potassium bromide is decomposed. Whenever we talk about the molten substances, always remember there is no other ion except the molten compound. So we are going to write the molten potassium bromide. So if we are talking about the molten potassium bromide, potassium ion and bromide ions are present here. So write the ionic equation for the reaction that takes place at the anode. So anode is the positively charged electrode. So negative ion will move towards the anode and positive ions will move towards the cathode, because cathode is the negatively charged electrode. So when bromide ions will go, always remember 2 bromide ions. This negative ions shows that it has one atom of bromine has 1 electron. One atom is going to lose 1 electron. When 2 ions are there, they will lose 2 electrons. And 2 bromine atoms will become bromine, Br2. So name the products and state the observation at the negative and positive electrodes when dilute aqueous potassium bromide is decomposed. So very much important question is there. If you are going to understand this question, you will understand rest of the questions related to the aqueous or dilute substances. So we are moving towards this. Dilute aqueous potassium bromide. Here is a question about the dilute. If both terms along with the, if only aqueous will be there, then we'll consider it as a concentrated substance. But here in dilute we have the ions of if I will show the ions here, if I will give you the understanding of dilute and concentrated here, you will be more familiar with this concept. Remember, dilute, aqueous, I think so, that was potassium bromide, if I remember that. Let me confirm. The question, yes, potassium bromide. So if we have potassium bromide, dilute, aqueous, okay, then in that case we have the ions like this, potassium and bromide ions, potassium ion and bromide ions. Along with these ions we have some more ions, those are of water ions, hydrogen ions and hydroxide ions. So these are the ions, potassium ion, bromide ion, hydrogen ion, hydroxide ions, which are present in the beaker as an electrolyte. So which ion will go or discharge at which electrode, we will check it here like this. Let me explain you this concept here. If I will write the reactivity series here, Kamal never calls me at Zoom. Full public has come to say hi. Assalamu alaikum UPT. Okay, this is the reactivity series for the positive ion, and if we are talking about the negative ions, then it will be Suno, Kal Barish Aayi. Oh, okay. So this is the reactivity series for the negative ions, and it is for the positive ions. Always remember, these ions will never ever be discharged in the, it will remain as it is in the solution. So here is the story. If dilute concept is there, then always remember this hydroxide ion will go, and for the hydroxide ion we have a set equation, that is the 4OH negative 2H2O plus O2 plus 4E. Memorize this equation as it is. So there is a detail of this equation. I will tell you in some other lesson how to write this equation, but you, for this, for right now, for the current, you have to just memorize this equation. Now we have, if there is the word dilute comes, for dilute we will also use this word, but if only aqueous potassium bromide are there, or the word used concentrated potassium bromide is there, then in that case we will not write hydroxide ion. Instead of this we will use this bromide ion when concentrated is there. But here is dilute, so we will, this hydroxide ion will go and will give us the product, that is oxygen. Oxygen produced here, this one is the oxygen which will produce in this reaction. Always remember, this is the negative ion, it will go at anode. And now come towards this, there will be no effect, either it is a dilute one or it is a concentrated one, or aqueous word comes along with the concentrated, but the effect on these ions will be on the, there will be no effect. The lower the metal ion present, it will discharge first. So ease of discharge is greater from the downward side, because in the upper one metals are more reactive, so they are not going to discharge in the process of electrolysis at their respective electrodes. So if we are talking about bromide ion will not go in aqueous form, if we're talking about the bromide ion will not go, and then potassium ion will not go. Hydrogen ion is present at the lowest part, so it will have a greater tendency to lose its to discharge at their to gain the electron and to discharge at their respective electrode. So 4 hydrogen ions will move over there and take 4 electrons and give 2H2 hydrogen gas. Now if we will move towards our paper, so name the products and state observations at the negative and positive electrodes when dilute aqueous potassium bromide is decomposed by the passage of electric current. So at the negative electrode, we have seen that the hydrogen gas will be formed. So if hydrogen gas will be formed, so product at the negative electron will be, if potassium, do not forget and do not disturb along with it, just write down here the ions, potassium ion and bromide ion. Dilute, if dilute is there, then hydrogen ion and hydroxide ion. Hydrogen ion is below the reactivity series, so at the negative electrode, product will be hydrogen. So observation at the negative electron, fizzing. The word fizzing is a better answer. But if you can write the bubbles of colorless gas, that will also be bubbles of colorless gas. Now I already have discussed about the detail. Hydroxide ion will produce an oxygen gas product at the positive electrode. Okay. They are talking about the product about the positive electrode. If we have this equation, 4OH negative plus 2H2O plus O2 plus 4E. For this reaction, what we will do? Water and oxygen is produced. Observation at the positive electron, again colorless gas, fizzing or bubbles of colorless gas will be seen. Colorless gas. Now we have to move on to our third question. The halogens are a group of elements in the periodic table. Chlorine is a member of this group. State the group number of the halogens. Group number is 7th group is of halogen. So 7th group, you can write it like this or you can write it like this, 7th group. In IGCSE, in your periodic table, it's 7th group, otherwise it can be 17. State how many halogens are there in this group. So in this paper, a new element is introduced. Let me show you that element. That is the, if I will make the close-up of it, I can show you. This one is, the spelling is not very much clear here, but I will check. Let me check here on the periodic table what basically element is. This one is tennessine. It's a little bit blur here, but it is a tennessine. If I will show you, but not in the previous periodic table, it is not present. You can see the previous periodic table, it is not present here. So this is the 7th group. Halide ions, they will form by gaining one electron. They have to gain one electron to become stable like noble gases. So here the new element is introduced here at this position. So 1, 2, 3, 4, 5 and 6. Look at this, how many number of elements are there? Fluorine, chlorine, bromine, iodine, astatine and tennessine, or tensine, whatever the pronunciation. 1, 2, 3, 4, 5 and 6. So how many halogen atoms are there? There are 6. Suggest the identity of the halogen with which has the highest density and the most reactive. So fluorine is present at the top of the group. If we're talking about the fluorine, chlorine, bromine, iodine, astatine, and let me check the symbol of tensine, TS. Always remember, as we go down the group, the density of the elements increases. So has the highest density, is that will be our new element, that is the tennessine. Okay, and fluorine basically as the most reactive. Why it is most reactive? Question arises why we are talking it's very reactive. The reason behind this, that fluorine is the smallest atom, so the number of electron, I'm just going to draw the valence electron of it. So the number of electrons, if you can check, here fluorine is present with 9 proton number. Okay, if I will show you all of the electrons, you can see 7, and in the first shell it is going to have, so it's a smallest atom, so great attraction from the nucleus part as well. Our nucleus is basically positively charged, proton is present, so negative force of attraction is greater, so it attracts that electron towards itself, rather than the next one where so many number of shells are added and it is going to be remain far away from the nucleus, so it will be difficult to attract. It is having a less reactivity because it is going to get the electron here with the a little bit with the less reactive than the fluorine. So fluorine is the more reactive non-metal because it has to gain 1 electron and its radius is very small. So from the force of attraction, from the greater nuclear charge, it attracts the force of attraction. So move on towards the next question. State the name negative ions, anions formed by halogens. Halide ions are formed by the halogens. Halide ions. State how many occupied electron shells are there in bromine atom. So bromine atoms, period number tell us, let me show you the periodic table. Remember, group number tell us number of valence electrons. Always remember, group number tells us number of valence electrons and period number tells us number of shells. Always remember that hydrogen and helium are in period 1. Okay, hydrogen and helium is in period 1. Where is bromine? 1, 2, 3. Let me 1, 2, 3 and 4. If I will show you the 1, 2, 3, this bromine is present here, and it's let me count from the beginning. First period, second, third and fourth. So bromine is present in the 4th period and it will have 4 shells. So number of shells will be decided by the number of periods. So how many occupied electron shells are there? 4. Name the noble gas which has the same electronic configuration as a bromide ion. So the question is very demanding. Now come towards the if we will see, there are 35 electrons in the, you can see there are 35 electrons in the bromine and there are 36, but bromide ion will gain 1 electron and bromide ion will have 36 electrons, whereas krypton has 36. So bromide ion will gain the electronic configuration like krypton. Okay, aqueous chlorine reacts with aqueous potassium iodide. One of the products formed is iodine. Complete and balance the ionic equation for the reaction between chlorine and iodide ions. State symbols are not required. So we can write here chlorine reacts with 2 iodide ions to form 2 chloride ions, and 2 chloride ions will be formed. So this is the ionic equation for the reaction between chlorine and iodide ions. Explain why this reaction is defined as a redox reaction. So redox reaction is a reaction when oxygen reaction in which oxidation and reduction taking place simultaneously. Okay. Now give your answer in terms of electron transfer. So remember one thing, we can describe this part with two ways. Chlorine is having oxidation state 0, but if we are talking about the electron transfer, minus charge shows that chlorine molecule has gained one electron. So chlorine atom is going to get one electron. Chlorine Cl2 is becoming chloride ions. So Cl2 is being reduced. Cl2 is being reduced to chloride ions, whereas iodide ions are being oxidized to iodine I2 because of loss of electrons. Let me tell you the easiest way to know which element is going to lose the electron, which is going to gain. Remember, this minus shows iodide ions has the negative electron. So if it doesn't have its electron in its neutral form, it means iodide ions have lost their electrons. So let me check, have I read the chlorine is being reduced because of gain in electron, whereas iodide ions are being oxidized to I2 because of loss of electrons. So the reaction in which oxidation and reduction taking place simultaneously are called as the redox reactions. Give the color and state of iodine at room temperature. Iodine has basically, if I am going to talk about the state of iodine at room temperature pressure is basically gray black, dark gray black, you can use the word, or dark gray. But if iodine is added in aqueous form, it is brown, red brown, or brown word is used, or in gaseous form it is purple. So the color of iodine at room temperature pressure is gray, black, or dark gray. State is solid. Question number 4. So carbonyl chloride is manufactured by reacting carbon monoxide with chlorine. The process takes place in a closed system and an equilibrium is reached. The conditions for this process are 200 degrees centigrade and 200 kilopascal. Explain what is meant by the term closed system. What is meant by the term closed system? A closed system is a system where no substance can enter or leave. Where no substance can enter or leave. State what the symbol delta H represent. So delta H represents the enthalpy change, and here delta H, what the simple enthalpy change is, overall enthalpy change in a reaction. State how the value of delta H shows that the forward reaction is exothermic. As you know that the value of delta H is given in negative. If delta H value is given in the negative, this one is negative 105. So negative sign tell us that this reaction is the exothermic reaction. Reduce the value of delta H for the reverse reaction. Obviously, forward reaction is exothermic, then backward reaction is endothermic. If we are talking about the forward reaction is exo, then backward is endo. For the endothermic reaction, we will have plus 105 value. Okay, so this is the reaction part of this. Let me move on. Okay, complete the table show effect of, let me write the equation here down, COCl2. Okay, move here, I'm going to write the equation here, because CO plus Cl, true, if I am not wrong. Yes, all are gases. COCl2. Reversible reaction, it is going to give us CaCl2, all are gases. No, we are talking about the the change to conditions. The temperature is increased. Okay, so this reaction is basically the, for minus delta H value is given to us. Forward reaction is exothermic and backward reaction is endothermic. If we will increase the temperature, by increasing the temperature, reaction will move towards endothermic side, and by decreasing the temperature, if this is one is the temperature, by decreasing the temperature, reaction will move towards the exothermic side. So if we are increasing the temperature, effect on the concentration of the COCl2, reaction will move in the backward direction, so concentration of COCl2 will be decreases. Some carbon monoxide is added. If we will add the carbon monoxide, find out this is the seesaw. Always remember, whenever we're talking about the reversible reaction, what's happened with it. For Cl2, COCl2. So you have to make a seesaw here. If we add some of the CO, the weight of this seesaw will be like this. So reaction will move in the, according to Le Chatelier's principle, reaction will move in the forward direction to undo this change. So what if it will move in the forward direction? So in the forward direction we have COCl2. So the concentration of COCl2 at equilibrium will be increases. The pressure is increased. Okay, come towards the pressure. By increasing the pressure, reaction will move in that direction where number of moles of gases are less. It will move towards fewer moles. So where are the fewer moles? 2 moles of gases are here, 1 mole of gases are here. By increasing the pressure, reaction will move in the forward direction where the number of moles of gases are less, so concentration of COCl2 will be increases. A catalyst is added. By a catalyst only speed up a chemical reaction, it will not affect on the state of dynamic equilibrium, so there will be no change by adding catalyst. So F part is, so this is the part F. The equation for the reaction can be represented as shown. Show some bond energies. Use the bond energies in table 4.2 and the value of delta H for the reaction to calculate the bond energy in kilojoule per mole of the carbon double bond. So carbon double bond O. So here are the bond energies which are given to us are basically minus delta, value of delta H is given, that is minus 105. So bonds broken on reactant sides. One point you all must remember, that is the always bonds are broken on the reactant side and energy is being absorbed. When bonds break, energy is absorbed. And whenever we are talking about the product, in product bonds are formed, always energy released when bonds are formed. So when bonds are formed, new bonds are formed, energy released. Now we have to move on. Look at the bond energies given to us. Calculate the energy needed to break the bond. We are going to write the bond energies of the reactants. Get the energy like this. Calculate the energy released. We have the, okay, so this is the structure for the carbonyl chloride. Fifth question. Manganese is an element with atomic number 25 in the periodic table. Calcium is the element with atomic number 20 in the periodic table. Complete table 5.1 to show the number of protons, neutrons and electrons in the manganese 55 atom and the 42 calcium ion. Manganese is an atom and calcium is an ion. Information is given in the question, so you can see that the 25 atomic number is given to us of manganese. So number of protons are equal to the number of electrons, so number of protons of manganese are 25. And for the calcium is the element with atomic number 20, so the atomic number is 20. Same number of protons and atomic number is same. So masses are given to us 55 minus 25 and 42 minus 20. We will get the value of neutron. Let me calculate. 55 minus 25. We will get the number of neutrons. And 42 minus 20. It's 22. Now come towards the number of electrons. So manganese is an atom. Number of protons are equal to the number of electrons. So it will be remain same. 2 plus charge. 2 plus charge means this calcium ion has lost its 2 electrons. So it will be 20. So for this one it is 20. These are the elements are given. Manganese forms several oxides. The formula of some of these oxides are shown, such as why manganese is expected to form colored oxides, because it's a transition element. Transition metals form colored compounds. So this one is the transition element or metal. You can write transition metal or element. State which other property of manganese shown by the formation of several oxides. A number of oxides shown by the variable valency or variable oxidation state. Oxidation state are basically the charge on an element. Like this, for example, we have the oxidation state of iron 2 plus. We can have Fe3 plus, like copper 1 plus and copper 2 plus. State the formula of manganese 2 oxide. Manganese 2 means manganese has the charge 2 plus, oxygen has 2 minus, similar ions cancel with each other. Formula will be manganese oxide MnO. Mn3O4 is found in an ore of manganese. Okay. Manganese metal can be extracted from Mn3O4 using aluminum as a reducing agent. Define the term reducing agents. Okay. The substance which is being oxidized itself is basically the reducing agent, and those substances causes other substances to be reduced. So we can define it like this: the substance that causes other substance to be reduced and itself, the reducing agent itself being oxidized. Reducing agent itself being oxidized. And for the oxidizing agent, it is the opposite. Oh, sorry. A reducing agent itself being oxidized. So the substance which is being oxidized by itself is the reducing agent. And same vice versa, you can talk about the oxidizing agent. Complete the simple equation by inserting the formula of the missing product and balance the equation. Okay, manganese is separate and aluminum oxide it can be aluminum oxide Al2O3. Aluminum has 3 plus charge, oxygen has 2 minus charge. Formula will be Al2O3. And now we have to balance it. It will get balanced like this: 3 8Al and 4 Al2O3 with 9 manganese atoms. So it's balanced now. MnO2 reacts with dilute hydrochloric acid as shown in equation. Calculate the volume of chlorine gas formed in centimeter cube when excess MnO2 reacts with OK. First of all, we have to calculate the number of moles. For calculating the number of moles, the values are given. If we are talking about the number of moles, so concentration multiplied by volume. Volume must be converted into decimeter cube. So 50.0 multiplied by 1000, we have to convert it in decimeter cube. Then multiply by with the concentration given 0.200. Let me calculate. Answer is 0.01 mole. So determine the number of moles of chlorine. So from here we have calculated the moles of HCl. From here we have to move here. For this we have to do the ratio method like this. HCl ratio Cl2. Take the number of moles here. 4 moles of HCl and 1 mole of Cl2. We will write 4 moles of HCl and 1 mole of Cl2. And if we have 0.01 moles of HCl, so what is the answer for the chlorine molecule? So X will be, cross multiplicate will be there, meaning we will multiply it. Let me move it on. It will be like this. X is equal to 1 multiplied by 0.01 divided by 4. And if we will divide these values, let me calculate. Answer is 0.0025 moles. Calculate the volume of chlorine. To calculate the volume of chlorine or gases, we have the formula like moles into molar gas volume. If we have to use 24 centimeter cube, we will use 24,000. 0.0025 multiplied by 24,000. Answer is 60 centimeter cube. So this is the way through which we have to do the question. Describe a test for chlorine gas. So chlorine is basically going to bleach the damp litmus paper. So we can take the moist litmus paper. We can take either one, moist or damp. Both are the same word. Blue litmus paper. First it will turn little red and then it will turn bleach. So chlorine gas, what it will do, it will bleach the litmus paper. Explain in terms of Killian theory why decreasing the temperature decreases the rate of this reaction. The number of points whenever we talk about the we use the bullet points as well to answer such kind of reactions. So explain in terms of Killian theory. So we are describing about the Killian theory by decreasing the temperature rate of this reaction. Okay, why decreased? Number one is the kinetic energy of the particle decreases. Energy of the particles decreases. Frequency of Killian per unit time decreases. Less successive Killian so less particles have greater energy than activation energy. So this is also the point which you can add it on. Last question. The structural formula of two compounds A and B are shown. A and B are members of the same homologous series. Give two reasons why the structural formula of A and B show they are members of the same homologous series. If they have the same functional group, if they have the same General formula. Both are alkenes. So they have same general formula. Same functional group. So here in these two molecules, these carbon to carbon double bond are basically going to show the functional group. Explain why A and B are both hydrocarbons. Because both have only hydrogen and carbon only. Contains only hydrogen and carbon in this compound. Okay. Write the symbol equation for the complete combustion of A. We have the C3H6. Oh, C3H6. Okay. C3H6 plus O2, CO2 plus H2O. Let me balance this equation. Oh, how this O2O is. Okay. If we will make it 2 3s are 6. Okay. We have to balance the number of carbon atoms. Hydrogen are 2 6 are 12. 2 6 are 12 here. Number of carbon atoms are 6. 6 CO2 are there. Now calculate oxygen. 2 6 are 12. 6 12 and 6 18. So 2 9s are 18. So it's balanced. Deduce the empirical formula of A. A is basically the C3H6. We can simplify it on the same table. 3 1s are 3 and 3 2s are 6. CH2 is the empirical formula. Name the compound B. Now come towards the compound B. Okay. CH. Okay. But 2-ene. But 2-ene. We can name it because at second number of carbon atom it contains double bond. So we will write but 2-ene. A structural isomer of B is a member of the same homologous series. Draw the displayed formula of the structural isomer of B. Compound B reacts with aqueous bromine at room temperature to form product C. Okay, addition reaction is there. So this state why this is an addition reaction, because only one product is formed. Answer is only one product is formed. So that's why we will call it the addition reaction. Describe the color change in aqueous bromine. Aqueous bromine is of orange color. When we will add aqueous bromine in it, the color of aqueous bromine will be decolorizes. So orange to colorless. Name the product C. It is 1,2-dibromobutane. Okay, 1 2 3 4. Okay. Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid. Okay. Of D. Carboxylic acid D has 2 carbon atoms. Okay. If it has 2 carbon atoms, then we will draw it like this. C double bond O is the functional group of carboxylic acid. 2 carbon atoms are there in ethanoic acid. This is the formula of ethanoic acid. Name the carboxylic acid D. It is the ethanoic acid. Complete the simple equation. For the reaction, oxygen is being added to form, we react with oxygen to form 2 moles of carboxylic acid. Okay, it is going to give us 2 moles of ethanoic acid, C double bond OH. So this is the end of the paper. I hope so that you people have learned it well. So consistency is the key of success. Signing off, Miss Aisha Manzoor.